Hello, my dear kids. Good evening. This is Mithun Raju, your science master, signing in from this part of the world, Cochin Kerala. Okay. I hope all of you are very well there. Okay, are you fine? I think hope you all are fine there. Anyway, in this part of the world, everything is fine here. The corona and everything is being calmed down a bit here, and also the weather conditions and everything is fine. Very fine weather condition now. Okay, so let us start with our syllabus. It's the third chapter of our 10th standard science, electricity. I think before, at the beginning of the chapter, I think it was a bit difficult, and by continuing each and every day, I think the chapter is becoming easier and easier. Okay. Okay, regarding the electricity, already half of the portions we finished. I think we finished till the Ohm's law. Am I correct or not? Yes, we finished till the Ohm's law and we started resistance. And we finished where what are the factors by which the resistance of a conductor is depending. So almost half of the part is done. Now there is a new thing called resistivity. After that, an important numerical will come, important equation, resistance connecting in series and resistance connecting in parallel. Okay, that's very easy part in that chapter. Regarding the numericals in that chapter, that resistance connected in series and parallels are very important, at the same time very easy. Every time 1 mark or 2 mark question is 100% from that part. So the next one will be regarding power. All these equations you will work it together and will make a new equation to find out the power. So what is power and all we will study in the next classes. And the last part will be heating effect of electric current. Heating effect of electric current and its applications, very important. Hmm. And one more part is there, I don't know what to do with that part. Actually from the NCERT textbook 2020 it is been removed. Hmm. For the from central board they removed that part, but there wasn't any declaration from the state government regarding that portion. But anyhow, I will do one thing. I will cover that portion. Okay, I will cover that portion. It's a simple portion regarding wiring or electric current or electric circuits in our household things. Okay, how we are connecting our household appliances in our home, in series or in parallel. Actually, it is in parallel. What is the reason and all? It's a very small portion anyway. It's a very small portion. 2 mark questions comes from that. One diagram is there, 3 marks. Not that much important. I think never asked before. Okay. Okay, that's it. Anyway, quick revision we can conduct one more time and we can start with resistivity. So the first we will study about what? We will study about flow of charges is called as current. Regarding current, we have one equation. What is it? So what we are going to study now, it is called as this one, called as the resistivity. Okay, material. Why I am written here material? Resistivity, material. Actually, there is nothing related to this, but we will talk about that. Something is very much similar between resistivity and materials, and it is expressed by, denoted by a special character called as rho. This is a special character, Greek letter called as rho. Okay, let me paste it here. I hope everyone can see that. Okay. So this is the thing. The first one we studied about current. What is current? Rate of flow of charges. Okay, rate of flow of charges. Charges can be described in Q, and rate of flow means time. Time taken T. So I is equal to Q by T is the first equation we studied in this chapter. Okay. Now using all these equations, what we are doing, we are deriving different types of equation. Almost the numerical part is 60% or 70% done. If you want to continue till resistivity, and after that power will also come. What you want to do? You want to be very thorough about these equations. It's very simple equations. The next equation is same like last year you studied in physics, the equations of motion. 3 equations of motions are there. Okay, regarding initial velocity, final velocity, acceleration, and what displacement and time. With that 3 basic equations of motion, you can derive equations for displacement, equation for time, equation for acceleration, equation for distance, equation for velocity, initial and final. The same thing we are doing here. But here in 10th standard, it's not that much difficult. Okay, not that much difficult, that much concepts are not there like you studied in 9th standard. Here we have studied the first equation is I is equal to Q by T. Never forget that. Rate of flow of charges. Q, the charge, rate of flow means time. Charges flown in a particular time is called as our current. So the second equation we studied, what was it? It was regarding voltage. Okay, and you know what is the standard unit of current? It is ampere, or we can write it as coulomb per second. Okay, coulomb per second is the real standard unit of current, but a common unit we find it out as what? Same like ampere. So in last day's quiz there was a question, what is the standard unit of work done? Some students wrote like Newton meter square by second square. Actually it is correct. But a common term is there called as joule. Okay, joule is also correct. The next part you study in higher classes, not that much difficult question won't come for 10th standard. Okay, application level questions will come, but these types of questions comes for CBSE. Understand? If you are going for study materials, most of them are relating to CBSE study materials. That much twisty questions won't come for 10th standard. Okay, 90% marks directly it will come. Only few 1 mark question and 2 mark question will be there. Application level. Okay, and numericals it will be directly from the textbook. Only the values will be changed. Okay, the entire exams the Karnataka state government conducted it was like that. Next year also it will be same. This year's science question was very easy, very easy. Okay, only 2 mark question was very difficult. So the next question was, next equation we derived was about the voltage, which is equal to V is equal to W by Q. W is the work done to take a particular charge Q from one place to another. Okay, that is the second equation we studied in this chapter. And the third one, you all know, our Ohm's law. A great scientist called Ohm derived a law. He found out that the potential difference across a particular circuit when the temperature is constant, at that time the potential difference and the current flowing through that circuit will be directly proportional. That is Ohm's law. Okay, that is Ohm's law. Very simple, isn't it? Actually, it was not that much simple. When Ohm, the scientist called Ohm, derived that, find out that, after that it became simple. Okay, so at a particular given temperature, okay, temperature must be constant. At that time, the potential difference or the voltage in a particular circuit will be directly proportional to the current. That means voltage increases, current increases. Voltage decreases, current decreases. That is directly proportional. And that proportionality constant is called as R. Resistance. Understand? V proportional to I. And that proportionality constant is R. Resistance. Something else is there in that circuit. Understand? Even though we are not connecting any resistor to a circuit, already that circuit have a resistance. Because a common wire will have resistance. Isn't it? You studied about silver wire, conduct more. Iron wire conduct less. Why? Because the resistance of silver is less than that of iron. So even the material also has resistance. Okay, the resistance differ upon materials. That's why here I wrote material. Understand? We'll study that. So these are the 3 equations we got. The last class we studied about the how resistance of a circuit is depending upon particular things. See, these are the things. Where is it? First one is resistance is depending upon length of a material. Not a material, conductor, sorry. For example, if I can take a wire, in this case we are taking a particular wire. Silver. Okay, silver. Silver. Can you see that? I wrote it small. Can you see that? Okay, fine, you can see that. this case I took a particular silver wire. Okay, this is the wire I have. Anyway, it does not look like silver wire, it is black. Very old silver wire. Just imagine that it's very old silver wire. So we have resistance of a conductor R. I will take another ring for that. Blue, where is my blue? Okay, come. R depends upon length. How? Directly or inversely? Length increases, resistance increases or decreases? If I am increasing the length, that means the length of a road increases. So it will take more time or less time? It will take more time, that means resistance will decreases. So length is inversely proportional to resistance. We can write it as this one. See, R inversely, you know the proportionality sign, isn't it? Okay. Inversely proportional to what? Length, L. Length we can say as L. Okay. So R is inversely proportional to length. So second one, I took another wire, same silver, which width is more. This wire has this much width. See, it's a bit thicker. That means what happened? In the case of the old road, this is our old road, very thin road, so high traffic, very difficult to travel, so high resistance. Our public work department, our government helped us. They made our road bigger, same traffic, but bigger roadway is there to travel, so resistance will decrease. Understand? So what we can say, R is sorry, R is directly proportional. Wait 1 second. I think here length will come upside. Sorry my kids. Here length will come upside. Wait. And area will come downside. Understand? You thought that? Okay, right. Actually R is, one more time from the beginning I will tell. See, directly proportional means R directly proportional to L, length. Okay, when length increases, what will happen? Resistance increases. So R must come upside. Inversely proportional means it comes down. Okay, division means it comes down. So next case, what happened? The width of a road increased, but same road. The road is made by silver. Understand? That's the main thing we want to keep in mind. The road is silver road. First, length increased, but traffic didn't change, so resistance increased. That means resistance is directly proportional to length. And next, area increased, resistance decreased, so it is inversely proportional to area. So we got another equation. Understood? And that proportionality constant in this case is called as what? Resistivity. So R, we can say R is equal to rho. This is the symbol of resistivity, rho L. L means length in meter by A. A is what? Area. This is the equation. Understand? Okay, this is the equation for resistivity. I will tell one more thing. Can you find out the SI unit of this length in meter? Area is what? Meter square, isn't it? Resistivity or anyway it is what? And for resistivity also we can find out the equation from this. Okay, that I forgot. That also we need to find. Now this is the equation of resistance connecting with resistivity, length and area. From the same equation we can find out another equation for resistivity. That is the important part we need to solve. Okay, we'll take another paper here. So we have what? Resistance R is equal to rho L by A. Isn't it? From here we can say rho is what? Rho is equal to RA by L. RA by L. Is it easy or not to derive equations like that? See, this is the first equation regarding resistance. This is the second equation regarding resistivity. And in this case, what metal we used? We used silver. Understood? Silver. Understand? So, from here we have rho is equal to Ra by L. Another equation, it will go here. That the fourth equation we studied in this chapter. Resistivity, rho is equal to resistance into area divided by length. Resistance, unit of resistance is what? Ohm. Unit of area is what? Square, meter square. Unit of length is what? Meter. Meter goes, square goes. SI unit is what? Ohm meter. Understand? Ohm meter is the SI unit of resistivity. Understood? Understand what is resistivity? Because resistance is directly proportional to length and inversely proportional to area. From that we can find out that R is proportional to L by A with a proportionality constant called as rho. From this we can find out another equation which is rho is equal to Ra divided by L. Understand? And this is very important part. Numericals will come 3-mark question. 3-mark question. If numericals comes from this part, it will be 3-mark question. Understand? In some times, no, I am not telling that now. If I tell means it will be getting trouble in your mind. Okay? We will to substitute. We will be finding it out only during doing the numericals. Now I am telling means it will be confused. Okay? First, you must thorough with these 4 equations. Till now, I think it's easy, isn't it? Okay, come back. Why I wrote this thing called as material? Why I wrote that? So next here, in this case I am taking silver. Next, I took aluminium. See, I am taking aluminium wire. Aluminium wire of same length and same thickness. Same. The same rod we used for finding this resistivity at the beginning, it was silver rod. The rod base was made up of silver, now it is made up of aluminium. Any difference will be there. You know that aluminium offers more resistance. Understand? The resistance of aluminium is more than that of silver. Silver has the highest conductivity among all the metals. Silver has the highest conductivity. But here now I am taking aluminium. So what will happen to this equation? What will change? Anyway, area and length is not changed. I have taken same length wire, same thickness wire. But the value of resistance is different. How? That's why this resistivity depends upon material. Keep that in mind. Resistivity of a conductor depends upon material. Understand? The case of resistance depends upon length. Resistance depends upon area of cross section. Resistance depends upon the material and also temperature. Resistivity depends upon only the material which we are using. And if we increase the length, if we decrease the length, resistivity won't change. Screw it into your mind. Okay? Resistivity won't change. There won't be any change in resistivity if we increase the length of the wire. Or if we increase the area of cross section of the wire. Why I am telling this means 1 mark application level question. I think 5 or 6 times already asked the same question. If we are increasing the length of the wire 3 times, I have a wire 1 meter long. The resistance is 2 ohm. I increase the length of the wire 3 times. What will happen to its resistivity? And what will happen to its resistance? That's a 2-mark question. How will you write? Resistance will increase because length increase, resistance increase. But in the case of resistivity, it depends upon material, not depending upon its physical property. Understand? Area increases, area decreases, nothing. Resistivity remains constant. But if change the material, then resistivity decreases. For example, I have taken three of you. Anyway, I don't know all the name of you. I am choosing a dog, a cat, and an elephant. I have three animals with me. Understand? A dog, a cat, and an elephant. And I have given 5 kg to each. I have given 5 kg. What I want to give? 5 kg of apple to all. Given to dog, given to cat, given to elephant. What will happen? Anyway, the elephant will eat the apple. Okay, leave it. Not that. Any change will happen for that apple. Apple is what? The resistance. Resistance won't change. But what will change really? For that cat, it will be difficult to carry 5 kg. Isn't it? Because the total weight of a cat is what? Only 1 kg. So its maximum ability to carry that 5 kg will be a bit difficult for it. But in the case of dog, at least 15 or 20 kg weight dog, it can easily carry that 5 kg of apple. But in the case of elephant, the elephant won't even know that 5 kg is it in the top of his body. That is resistivity, that ability, that strength. Understand? Wherever you take that dog, elephant and cat, the ability to carry that weight will be same. Like that, this resistivity also is like that. It's a particular ability to increase the resistance. Same like resistance. Okay, resistivity and resistance are closely linked with each other. But resistance vary with length and area. But resistivity won't vary with length and area. It only depends upon what? It only depends upon the material it is made. Okay, that is the fourth equation we studied yet. Anyway, that was a good example of dog, cat and elephant. I also didn't understand about that. Why I used that example, I don't know. Anyway, nothing relating to that. Just imagine that resistivity does not depend upon length or area. It depends only upon the material it is made. But resistance, it depends upon length, area of cross section, material it is made and temperature. Resistivity in extreme cases, temperature dependent is also there. Understand? In extreme cases. But that you are not studying in 10th standard. Okay. In high temperature, like a superconductivity, you heard about that? Anyway, it is for PUC, not for your 10th. I will just tell what is superconductivity. There is a particular property of certain metals. When they are if we bring down that temperature to 0 Kelvin or minus 273 degrees Celsius, it will become superconductor. That means zero resistivity. Zero resistivity, that means if we can make metals with zero resistivity, there won't be any power loss in the world. Understand? There won't be any power loss. So scientists are working out that. But it takes extreme temperature like minus 273 degrees Celsius. But our room temperature is not that. We cannot even imagine that temperature. We will die. So as soon as we are facing to that temperature, we will die. But if the scientists in future, they were able to bring that superconductivity in conductors at room temperature, there won't be any wastage of energy. Think about a life where there is no current bill and all. Who knows, in future it will come. Or not now. Okay, that's it. Let me see, anything else is there. Resistance, electrical resistance of a conductor changes with its change in length and area of cross-section. Electrical resistance of a conductor remains constant at a particular temperature. Okay, and in the basis of resistivity also, the materials are divided into three: conductors, insulators and semiconductors. You already studied that, same. And in this case, resistivity of conductors are very, very low. Understand? Very, very low. It varies at 10 raised to minus 8 or 10 raised to minus 6. There is a particular chart in textbook. Okay, I will give you today's homework. That's the homework. That photo I will give you, resistivity of different metals. That is important. Understand? That is important. I am not telling that you want to by heart all those things. If you can study all those things, it will be good. But what you want to do, you want to understand all those things. Some of the things are important. Size of the metal with high reactivity, low reactivity. And in the case of metals, silver is the particular metal which has the maximum conductivity power, and alloys, they have very high resistivity. At this high resistivity of alloys, we are using it for home appliances like our home iron, electric heater, water heater and all. So application level questions are there from that part. We will study in the next classes. Okay, nothing else is there. Insulators resistivity will be very high. Understand? Very high. Almost zero current is passed through an insulator. Semiconductors, half conductor, half insulator. Okay, you study about semiconductors in PUC, not in 10th standard. A particular subject is there. Electronics, very interesting part, my favorite part. One question I will tell. See, this is a question, application level question. A wire of resistivity rho is stretched to 3 times its length. A wire, its resistivity is rho. It is stretched 3 times to its length. What will happen to the resistivity of the material of the wire? And what will happen to the resistance of the material of the wire? Just imagine a wire is 1 meter, 1 ohm resistance. It is stretched 3 meters. What will happen to the resistance? Resistance will increase. Resistance will become 3 ohm. What will happen to resistivity? Resistivity will remain the same. Isn't it? Yes. Okay, that's it. Copper and aluminum have low resistivity and high conductivity. Silver is the metal which has the high conductivity. Silver has the lowest resistivity of all the metals, but why it is not using in transmission lines, you already know that. Why? Not only because it is expensive, but if you use silver in outside transmission lines, what will happen? Every day we have to replace it, isn't it? Because it is expensive, everybody will come and store it. I am sure you also will do the same, isn't it? Simply we are getting that. Imagine it is made up of gold. Okay, silver, it is made up of silver, you won't go to rob it. Okay, fine. What if it is made up of gold? Think about that. Okay, my dear kids, that's it. That's the thing we want to study about. 4 equations, 4 important equations we studied already in this chapter. And these 4 equations we will use to derive the equations of, actually power equation we don't want to derive. There's a particular equation for power is there. But regarding these equations, there's a lots of application level. Numericals will come from this chapter. This is the main thing. This is the heart of this chapter. Understand? All the other things, just read, you will understand. These are the things, how to get this equation. I think till here it was easy. This also was IDC part, isn't it? First one, what is current? I, Q by T. Rate of flow of charge by time. Charges divided by time. I is equal to Q by T. Unit is ampere or coulomb per second. Voltage, work done to take a unit charge from one place to another. Work done, W. Charge, Q. Work, Joule. Charge, coulomb. Joule per coulomb is the what is that? Unit. Next one is Ohm's law. Potential difference and resistance, not resistance. Current is directly proportional. Proportionality constant. Resistance R, V is equal to IR. It is a universal law. Understand? Very important law. Like Einstein's mass energy relation. VE is equal to mc square, like that. V is equal to IR. In some book it is written as E is equal to IR. Electric potential is also written as E. Next one is resistivity. Directly proportional to length, inversely proportional to area, proportionality constants, rho. So rho is equal to Ri by L. Unit is ohm meter. Isn't it? So that's it. I hope you understand this part. Next day onwards we will continue the next class. Next day also we can continue that series and resistance connected in series and resistance connected in parallel. That also we can go through with this written classes. Even I have that PowerPoint presentation and all, but somehow I am getting bored by doing that. This is more interesting for me to do, use a board and all. So my dear kids, till then, stay safe, stay home. Today also we'll conduct a quiz, and those who get good marks during that exams, congratulations to all those students. It was very difficult to, I know it is difficult to get full marks in physics or all. Even 80% is very difficult to get at the beginning time. I'm not telling the ending time it will be the same like this. The beginning time it is very difficult to score in physics. But those who scored very well, Congratulations to all, especially those who got above 20 marks. Well done, my dear kids. Proud of you. See you soon. Bye bye and Jai Hind.